simplify the rational expression to the lowest term. This is the first thing we did in this unit, okay? So if there's anything that we can cancel, we're going to cancel that out. So in this first problem, is there anything that we can cancel on the top and the bottom? X minus 1. Now notice how it has that squared in the bottom. That means we're only going to cancel one of them. Okay, I'm going to rewrite this as 2x plus 3 over 2 times x minus 1. Now, when they say state excluded values, that means any holes or vertical asymptotes must be defined. So we can say x cannot equal 1, because that would be the solution to the denominator, right? And that's it. Okay, are there any questions on that? Okay, on the second one, we've got to factor first. I want you to take a moment, try to factor the top and try to factor the denominator. So in the top, when we factor, remember, we've got that ax squared plus bx plus c. When we factor, we're going to take a times c and put it in the top. We're going to put b in the bottom, and we're going to ask ourselves, what times what would give us whatever a times c is, and add together to get us b. So in this instance, we're going to have -6 and 5. What two numbers can I multiply together to get me -6, but add together to get me 5? Multiply to get me -6, add together to get me 5. This one's always, I always mess this one up too. So -1 and 6. Because remember, it's got to add together to get me +5. Okay. All right. So that's going to make this in factored form x plus 6 times x minus 1. In the bottom, we're going to factor as well. This time we don't have a b term, but a times c is going to give me -36 and b is going to give me 0. What two numbers will make that happen? 6 and -6. I'm going to put that in the bottom. So x plus 6 times x minus 6. Now, is there anything that we can cancel out? Yeah, that x plus 6. Okay, so we're left over with x minus 1 over x minus 6. And we're going to state the excluded value. So we're going to say, hey, x cannot equal anything that we crossed out and then anything that's in the denominator. So -6 and 6 we could not have. Fractions, which is from like 4th, 5th grade. Okay. When we were multiplying fractions without using a calculator, what your teacher would tell you to do is they would say, what are the factors of these? And see if you could cancel. Yeah, give me 1 second. Of what are factors of 20? 10, 5. Okay, we're going to break this down into 5 and 4. Okay, what are factors of 9? 3. So 3 and 3, right? Okay, what we're going to do now, I'm gonna actually rewrite this to make it a little easier. We're going to say 3/5 times 5 times 4 over 3 times 3. Are there any repeats in the top and the bottom? In the top and the bottom, are there any repeats? Yeah, there's a 5 in the top. There's a 5 in the bottom, so those can cancel. There's a 3 in the top and a 3 in the bottom. Okay. And anything that we're left over with, we're just going to rewrite it. So we're going to get 4/3. If you were dividing fractions, your teacher told you to keep, change, flip, right? They always call this like the KFC thing, but actually it's KCF. It's fine. you're going to keep this first fraction, change the sign of the middle operation, and then flip the last fraction. So keep, change, flip. I'm going to keep the first one, change it to multiplication, and flip the fraction. Now this has gone from a division to multiplication. So now we're going to repeat the same process that we did on the first one. We're going to factor this out and see if we can cancel anything. What are factors of 15? 3 and 5, right? What are factors of 4? 2 and 2. So I'm going to rewrite this. I'm sorry, this is at the bottom. 2/5 times 3 times 5 over 2 times 2. Is there anything that I can cancel from the top and the bottom? 5 and 5, 2 and 2, and whatever I'm left with, I'm going to rewrite. So 3 halves. Never had to use a calculator. Okay. That's why they call it algebra 2. Okay. So if you have any repeats in the top and the bottom, you can cancel them out, right? If you have factors, you can also cancel them. So looking at this first one, can we break this 4x cubed down? Not really, but what we're going to do is we're going to say 4x, x, x, because there's 3 x's, right? Down here, we're going to rewrite this as 4x, x. What are factors of 21? What was it? 7 and 3. Okay, so I'm going to rewrite this whole thing. I'm going to say 3 over 4xx times 4xxx over 7 times 3. Is there anything that I can cancel in the top and the bottom? Okay, so 4s. What about 3s? And I can cross out what? 2 x's from the bottom and from the top. Anything that's not crossed out, I'm going to put it over here. And I'm going to give you a second to catch. We do have to state the excluded values. One thing to keep in mind is anything that you crossed out in the top and the bottom that had an X, that's an excluded value, right? Okay, so, yep. Okay, so that means that what we crossed out here, we had X's in the top and the bottom, right? So that means that an excluded value would be X cannot equal 0. Remember, we crossed out this 4x squared. If we set that equal to 0 and solved, that would give us x equals 0. That's why it's an excluded value. Does that make sense? Okay, so here it is again. Anything that I crossed out in the top and the bottom that had an x in it, which we essentially crossed out a 4x squared. See how we crossed those out? Okay, if we set that equal to 0 and we solved, we would get x equals 0. But if we plug that back in our original problem, that would make it an excluded value. So this is our final answer. Can you take a moment and can you see if you can cross out anything in here, write out the simplified version, and state the excluded values? Try the next one. The next one, is there anything I can cross out in the top and the bottom? X plus 4. Okay, cool. And anything that we're left with, we're going to rewrite. Now, we have to state our excluded values, which is any vertical asymptotes and any holes, right? So anything that we just crossed out, that's an excluded value. So you told me that we crossed out x plus 3. So that means that -3 is going to be an excluded value. You told me that we crossed out x plus 4. So that means -4 is going to be an excluded value. And then we have this 3x plus 1 in the denominator. So we're going to take that, set it equal to 0, and then solve. When we solve that, we're going to get x equals negative 1/3. So that's also going to be an excluded value. Third one, I'm just going to write it a little bit higher. Okay, so on this third one, we're going to factor first. Okay, again, in this unit, you want to factor first. So over here on the left-hand side, we're going to factor what's in the top. So we're going to say a times c, which is -4. B is -3. What two numbers can I multiply together to get me -4, but add together to get me -30? So what two numbers can I multiply together to get me -4, but add together to get me -3? That's going to be -4 and 1. Now here's the new part. If my coefficient in the front is bigger than 1, then what I'm going to do is I'm going to take that coefficient and divide by both of these. Okay, this is called the slip and slide method. Okay. So -4 divided by 2 is going to give me -2. So I'm going to rewrite this as x minus 2. If it gives me not a whole number, then I'm going to take what's in the denominator, slip it to the front, and move this guy over. So this is going to give me 2x plus 1. Now I'm going to factor what's in the denominator. Now this isn't a squared, or it's not a quadratic. So I'm going to take out my greatest common factor from this, and that's going to give me 3 times x minus 2. So again, I took out the greatest common factor from this, and I divided both of these by 3. In this numerator on this side, we can't factor this, so we're just going to bring it up down. And then down here, we're going to factor this. So we're going to say a times c, which is -4, b, which is 0, because there's no b term. What two numbers can I multiply together to get me -4, but add together to get me 0? -2 and 2. Again, you must pay attention to the fact that the coefficient is bigger than 1. So since that's the case, I'm going to take each one of these and divide it by that coefficient. Since it's not a whole number, I'm going to simplify the fraction first and then bring it up and over. So what I mean by that is both of these are divisible by 2. So this actually can be simplified to -1/2, and this guy can be simplified to 1/2. Since that's not a whole number, I'm going to take the coefficient, move it up, push this guy over. So this is going to be 2x plus 1 and 2x minus 1. I'm going to give you a second to finish writing that down, and then we'll talk. That we have repeats in the top and the bottom. So we're going to cancel out any repeats. And what we are left with is 6x divided by 3 times 2x minus 1. Now, looking at this coefficient right here, you know what 6 divided by 3 is. That's going to give me 2x over 2x minus 1. Again, we have to state the excluded values. So that's x cannot equal 2 and -1/2 and +1/2. Yeah, that got a little long and a little low. Okay, So notice how this went from being a very easy problem to a very complex problem. Okay. Very similar to how multiplying is. You're going to still factor. The biggest thing that you're going to do is keep, change, flip. Okay. So again, keep, change, flip. So first, we're going to go ahead and do that. So we're going to say keep, change the sign to multiplication, and then flip the fraction. Okay, does everybody see where I got the keep, change, flip from? So I'm going from division to multiplication. Okay, and then I'm going to factor. Well, this fraction right here is already in factored form. We don't have to do anything with that, so we're just going to go ahead and rewrite it. Over here, we're going to factor the top. We're going to say A times C is going to give me 25. B is 10. What two numbers can I multiply together to get me 25, but add together to get me 10? That is 5. Yay. All right, so I can write this out as m plus 5 times m plus 5. In the denominator, we have our A term and our B term. So from here, we're not going to do like the little X method. We're just going to take out the greatest common factor. So from these two things, I can take out an m. And when I do that, I'm going to get m plus 5. Okay, so for division, step 1 was keep, change, flip. Step 2 is to factor. Step 3, we're going to cross out or simplify. Step 4, state the excluded values. Okay, so now we're going to cross out. So we can cross out that m plus 5 in the top and the bottom. We can cross out that m plus 5 in the top and the bottom. And we have an m squared in the top and an m in the bottom. So we can cancel one of these from the top and one from the bottom. So what are we left with? Just m. Look at how we started with this mess and we just got m at the end. Now for the excluded values, we're going to say that m cannot equal, and anything we crossed out, it can't equal. So that m plus 5, that's going to switch to a negative 5. That m that we also canceled out, that's going to be 0. This is our final answer. Okay. So on this last problem, we have a fraction divided by a fraction. This is just a really complicated way of saying the exact same thing that's going on up here. Okay, so this is saying x squared minus 4x divided by x squared minus 8x plus 16 divided by 12 divided by 2x minus 8. That's all this is saying. Then you do it the exact same way we did it on the last problem. You keep, change, flip, and then factor, and then cross out, and then state your excluded values. Okay, so I'm going to erase this part and write it up here so that you can actually see it. Okay, so we're going to keep, change, flip, keep the first one, change, and then flip. I'm going to factor. So in this top part, I'm going to get x times x minus 4. In the bottom, I'm going to get x minus 4 times x minus 4. Over here, I'm going to get 2 times x minus 4. And in the bottom, I'm going to have 12.